Let's see how can we improve the previous code using the modulus operator. The first thing here, by the way, I replaced the list with the list comprehension. Here in this code, I'm iterating the key iterations. Remember here, we have this if condition. If you reach the end of the cycle, then please go back to the first item of the cycle. Here in this one, I am replacing all of that with a single line of code here. I'm replacing that with last position plus 1 and then applying the modulus. So the difference is we apply the plus 1 and then we check n equals 0 then to move to 0, but here I replace this with a modulus n. Let's say that the last position now is 4, and for example let's say that n is 5. Here when you increment last position, it now 5 is 5 equal 5, you return him back to 0. But here when you make it 4 plus 1 5 modulus n, 5 modulus 5 will be 0. And here the last position modulus n2, the last position modulus n, if the list shrinked one step and we were at the last position, then again modulus n will return us back to 0. So from one side, the modulus n pushed us to get rid of this extra if condition. However, this also has the effect of handling the very big K. Why? Let's say that here, let's take this one further step in an improvement. Now I'm going to get rid of all of this for loop with only this single statement. In this for loop, we were iterating k-1, which are all just plus 1 mod n plus 1 mod n. What if I just added all of the steps at once and take a modulus n? Then last position will be the same value. If here we were incrementing 3 times to get modulus n after every step, mathematically it is the same as adding 3 at once and then taking the modulus n. But a great advantage of this solution also, what if k is very huge? Then we are, remember the useless cycles of a clock, every 12 cycles are useless, right? Like every 12 cycles are useless. In the same way, let's say that you are in a circle here and the circle has just 5 people. And then let's say that your counter is 20, for example. You iterate 5 and get back to 1, iterate 5, get back to 1, iterate 5, get back to 1. These are all useless cycles. If you observe it, if the number of alive is 4 and k is 6, this is as same as number of alive 4 with k10, same as number of alive 4 and k equal 2. The modulus can get rid of us of all of these useless cycles. So here we are adding the k-1 steps that we would like to do and then applying the modulus n at once. So this will get rid of all of the useless cycles, and with this also we get rid of all of this code. Now observe the code overall is very efficient in terms of getting rid of this code. That's all.